Hey there, this is Seth Schaefer from Team Just 'Cause Robotics, and in today's video I'll be doing an unboxing. I never do unboxings because I never have products to review, and this also isn't really a review either. So I want to get the full disclosure part of this out of the way early. This is the Creality Falcon 2 22 watt diode laser. Now, I was sent this product for free, and in exchange, I'm expected to make 2 videos about it, but neither of those videos have to be reviews, and it's definitely a conflict of interest for me to put affiliate links for this laser below a review video, because I have absolutely no incentive to give you my honest opinion if I get paid every time that somebody buys one. So instead, I'm going to make 2 videos where first I'll talk about projects that I could actually use this for and its uses for combat robotics in prototyping and in decorating your bots, because you can etch onto metals and etch away paint on painted surfaces, and you'll also be able to cut out acrylic, plywood, and several other plastics and other materials, which are really helpful for at minimum prototyping, if not actually making functional parts of maybe an ant-weight robot or a flea-weight robot. I also want to compare this to my experience using other laser cutters, because this is nowhere close to the first laser cutter that I've used. When I used to work at DECA, I extensively used a Boss 60 watt 24 by 36 inch CO2 laser, and I also formerly used to work at IPG Photonics, who manufacture fiber lasers, and at a previous internship that I did, I got to work with a small fiber laser made by Fablite that was a metal cutting laser, in addition to a giant 48 by 48 inch CO2 laser. So I have lots of experience using a laser cutter. I probably used the laser cutter more than any other single tool when I was at DECA, but using a diode laser, this is actually going to be my first time, even though I've used fiber and CO2 lasers, which ironically are far wildly more expensive and capable in a lot of ways than this. Now, it's not to say that you can't do a lot with a diode laser, but a 22 watt diode laser is not the same as a 60 watt CO2 laser or a multi-kilowatt fiber laser that can cut out parts at send, for instance. So I'll get into all the differences and the information that you need to know about this as the video goes on. But first, I guess I'll unbox it, because I have never unboxed a laser cutter before, so let's see what that's like. Alrighty, that looks pretty nice. So, one of the nice things about this laser that makes it different from a lot of cheaper diode lasers that you might find is this right here. This is an air assist pump, and it's pretty critical for making nice looking engravings in most materials, because without the ability to blow away the fumes that are produced as the laser is going along and engraving, and especially trying to cut deep through thick materials, getting those fumes out of the way that are blocking the laser light from getting through becomes really important. So this is a really, really nice addition to this laser. However, there are some other there are plenty of CO2 lasers that come with air assist built in or a separate air assist unit, and there are other diode lasers that come with separate air assist units as well. This one has Creality's logo emblazoned on it, but I've seen very similar looking ones from companies like X-Tool. We also get some Allen wrenches that I guess we'll need to assemble this, a card reader, and a USB type A to C adapter for plugging this into your laptop, and it comes with a lens, which is nice. I'm assuming replacement lens and a cleaning cloth, some Velcro for some reason, and there's also these keys that you use to turn the laser on. So if you had a small child in your household and you didn't want them playing around with your dangerous laser, I have no idea what I'm doing. I've never unboxed anything on camera, and I certainly haven't unboxed a giant freaking laser cutter, but it looks like they came with a variety of materials here. Engraving, cutting of thickness of basswood, cutting thickness of basswood, and cutting thickness of basswood greater than 6mm. So it looks like this is a focusing tool, so how far away the laser is from the surface. So you get a lot closer for cutting greater than 6mm thick, or medium for 4 to 6mm thick, or very far away for engraving stuff 1 to 3mm thick, because the laser is focused at a fixed distance, so it'll make a cone of light. It's a narrow cone, but a cone of light as it's going through the material, so you get taper when you're cutting thick material. That's unavoidable with pretty much any standard laser cutter. I don't know of any laser cutters that have a tilting head to adjust for that, but you can, in some fancier lasers, get a longer focus distance lens, which makes that cone narrower, that makes the taper a lot less of an issue. With these diode lasers, they're focusing not very far away, so the taper might be more of an issue if you're cutting thick materials, but most diode lasers aren't powerful enough to cut through thick materials anyway. This is a 22 watt. There's also a 40 watt version of this that can cut presumably even thicker, or at least even faster than this one can. This is the laser head itself. It's pretty beefy. Now, if you've watched any styropyro videos like I have, or you've watched other laser reviews, you might be aware that usually you can't really get a diode laser that is more powerful than a few watts with a single diode. This actually has 4 separate diodes in it. And you can see here it tells you the wavelength is 455 plus or minus 5 nanometers. This is very important. If you are buying laser safety glasses, you need to get the correct ones for this wavelength of light. This is a visible light laser, so somewhere between 400 and 700 nanometers is the visible light range. So on the 400 end range, this is going to be something like a blue or purple light, and that means that it interacts with materials the same way that any purple light would, just very, very intensely. So for instance, I have a piece of clear acrylic here. This was cut on a CO2 laser. The CO2 laser uses, I think, 1030 nanometer light or 1060, somewhere in there, which is outside of the visible range. And clear acrylic is obviously transparent to visible light, which is why you can see through it. However, it will also be transparent to this laser, whereas for an infrared laser or a CO2 laser can cut this out just fine. Fiber laser cannot really interact with most plastics at all, but it can cut metals. That's just down to the energy level and the wavelength of the light and how it interacts with different materials. One thing I appreciate about this laser head is they've got this little see-through window that's tinted that hopefully is the correct tint to block the laser light of this frequency. Like I said, this is going to be basically go blue or violet. So you can see this is orange, so it lets, red and yellow light through, but it should block the opposite colors like blue and violet, which is why it is orange. I assume that they shipped laser safety glasses with this, but I don't necessarily, so like these are green laser safety glasses, which is not opposite of blue, so I don't necessarily trust any laser safety glasses that come with these cheap diode lasers. So I actually bought my own, which are also tinted orange, and these were about $70 on Amazon. I'll put an affiliate link to buy these in the description because I do not trust these like probably $2 laser safety glasses to save my eyes from the laser. But I am glad to see that they include a protective color film on here that is the correct color to actually block this wavelength of light, so that gives me some confidence. I'm not saying that these are definitely worthless, but they could be worthless, and I'm not willing to take that chance. I don't have the equipment needed to test if this actually blocks the blue and ultraviolet ranges of light. Oh, one other feature that was advertised on this laser that I don't know if many others have is it has a flame sensor, so it'll presumably turn the laser off if your material catches fire. So there's actually 3 LEDs, and it will warn you if the lens is dirty, if there is not enough airflow, and if what you're cutting is literally on fire. Alright, so included with the laser are a bunch of sample materials. I assume these come with the laser no matter whether you're getting a review sample or not, but I don't know for sure. So it looks like they've got a piece of stainless steel here because this laser can engrave stainless steel. It shouldn't be able to cut anything close to this thick, but it can engrave steel. You can cut stainless steel with this. They advertise 0.05 millimeter thick in one pass, and I saw a video where somebody used a similar laser to cut through a couple thousandths of an inch thick metal, or stainless specifically, but you will not be able to cut something this thick. This is like a solid 1/16 of an inch thick. Another thing with metals is they will warp as they are heated up with the engraving sometimes, so a thicker piece like this probably will resist warping, but thinner sheets very likely will warp pretty significantly from the heat. And it looks like they included some foam or felt that you should be able to cut. You can cut most organic materials with a diode or a CO2 laser. One thing you have to be very careful of is you don't want to cut plastics that have any sort of vinyl in them, because they will release deadly chlorine gas as they are cut, so that is extremely important. But it looks like this is a bunch of like thick paper, cardstock foam. Some foams will have vinyl, some won't, so definitely watch out for that if you're ever trying to cut some foam. But cardstock, paper, wood, and acrylic plastic are all fair game. I believe you can cut Delrin, but again, you want to be avoiding fumes from that, but you can cut it. Any diode laser like this is going to produce a ton of fumes, and because there's no enclosure with this, you're going to have to figure out some way of evacuating those yourself. So I'm probably going to actually use this outside because I live in a small apartment without good ventilation. But another option would be for me to open the sliding glass door next to me and point a fan over the top of the laser, just pointed straight outside. It looks like Creality was nice enough to send me their Rotary engraving kit, so you can use this to engrave mugs, to engrave like powder-coated metal things. I obviously haven't used the laser for anything yet, but I'll show you an example of this because I got one from Deca. So this is laser engraved stainless steel. You can see that text here is what was laser engraved on here, and hypothetically I can do something like this using that rotary attachment, which is pretty cool. I didn't actually know they were sending that with the laser, so that's nice to see. Also, just want to comment, looking at this, this looks extremely well made. This is like super thick metal, like way thicker than it, and beefier than this probably needs to be. Just like a single continuous bent piece of metal along here. Might actually be an extrusion that they just add drill and tap holes to for this piece. Yeah, definitely very well made, and as you would expect from Creality, extremely well optimized for mass production because they probably ship, you know, thousands and thousands of these a year. So one thing I noticed when I pulled the laser module out is the laser module has a USB-C port on it. I was curious what that is. Apparently you can update the firmware on the laser like motion system itself, and then there's a separate firmware just for the laser module, interestingly, that you can upgrade by using the USB-C port on the laser module. But I'm not sure why they don't just have a communication between the whatever computer is in this like base and the laser module that could update the firmware through that, but whatever. Maybe they're manufactured by two different third-party companies. I have no idea. Alright, should probably take this out of the box. So there's rubber feet so that it doesn't slide around on these things, but it also came with 4 pairs of these extensions for the feet, so you can prop it up pretty tall for cutting thicker stuff. And I guess you need it this tall to use the rotary, most likely. Oh sweet, it came with the honeycomb bed too. It says that's optional to use with it, but it's there. Oh sweet, and a huge plate of aluminum too. I guess that goes underneath this to prevent it from penetrating whatever surface it's on. Alright, so according to the user guide, everything that I got is included other than, it looks like, the rotary attachment. So it does actually include material samples, at least for basswood, and there's some cleaning cloth and the metal protection plate, whatever that is. But I do not think it normally comes with the honeycomb bed or the rotary attachment. Naturally, as I'm trying to finally look at the user manual, my laptop decided Windows updates would be a fantastic thing to do. Cool. One thing I notice immediately on the side here, there's an air pump interface, and this is a different port. It's the same size, but it's a different port than the power supply, so that's smart because it means you can't accidentally plug the power supply into the air assist output, because I assume that would do horrible things to this thing. On the front, Falcon 2, we've got this big, nice tactile buttons. Doesn't feel super cheap or anything. It feels pretty good. There's a frame button. This will draw an outline of where you're cutting, and then big play button. On this side, classic power switch, which somehow was in between off and on out of the box. So that'll be your on-off. You got your actual power input, you've got a USB-C for updating the firmware on this guy, and you've got the micro SD card slot nicely labeled on here in those white labels. You got your e-stop, always important. This is a proper e-stop, you have to twist to undo it. I like that. This is also known colloquially as the oh shit button. And then on the back, you've got a QR code, which I guess is just the serial number, and some information about the power usage, I assume. Whoopsie. Oh, it just moved on its own. So this is 120 watt rated power, Falcon 2 22 watt laser, etc., etc. I believe, even though it says on this sticker on the frame itself that this is the 22 watt laser, that there is a 40 watt head upgrade that you can do with this as well. But that remains to be seen. There is also a separate 40 watt version of this that I think is available for pre-order now, or maybe you can buy it already. Oh, let's see that. They have the air hose and the power, the laser, routed nicely in this like cable track thing on the side here. I like that. Can you even see that on camera? Yeah, you can. Okay, sweet. Please ensure this machine works under supervision. One time. You don't have to use it under supervision. You just have to ensure that it works under supervision. So interestingly, there appears to not be any sort of Creality G-code generating software that's included with this laser for free. I've used Lightburn before, so I'm just going to download the free trial of Lightburn. It's a 30-day full free trial. I've used Lightburn already, so I'm familiar with it, and I know it's pretty much the best out there for hobby lasers. So let's just do that, why don't we? Now, there is no way to use the laser by itself. You need a laptop, whether it's constantly connected to it to stream the G-code, or whether it is to actually just generate your files. You'll need a computer of some sort, and you can, in theory, put them on the SD card, stick the SD card into the laser, and then have the laser operate offline or anything, but there's no like Wi-Fi connectivity with this or anything like that. Still going for another minute and 10 seconds, it looks like. That's my logo, alright. That's pretty nice. So it looks like taping down the card really helped. At least it helped with it skewing and getting all weird, but yeah, the definition on the QR code's definitely usable, but it's not like incredibly clear. The scan-lined logo though looks pretty good. And yeah, the QR code does scan still, so that's the important part. So if you actually want to see the laser dot, the best way to do it is to just raise the laser so it's really far out of focus. And then it's actually visible because it's diffuse enough that it's not just like a hot, bright spot that you're looking at through the cover. And then you can focus it. Alright, so I was playing around with this design maybe a month ago for kind of like a Tomb Clone-esque bot, and this is meant to be like a 2.5D kind of part, but there's no reason I can't prototype it by just cutting it out in a 2D fashion without these pockets and the countersinks. So I figure this would be a good test for the laser, And I went to Home Depot and bought some 1/4-inch material. These parts were designed to be used with 4mm and 3/16" thick material, but just to get some idea of like what the shape looks like and how stiff it is, I think 1/4-inch plywood or MDF would be a good test. So let's see how fast it is to cut this out on the laser. I'm interested in seeing how much time I could save by prototyping with the laser instead of 3D printing. So I pulled up the parts in Bamboo Slicer here, and for a Bamboo Slicer to make these parts, it would take about 2 hours, or 1 hour and 45 minutes to print both of these. I bet that I can cut them out in the laser in less than 1/5 of that time. So let's see what it'll actually take. Alrighty, let's start the timer and see how long this takes. Take and says it'll be about 10 minutes. 10 minutes instead of 1 hour and 45 minutes. Let's see if you can see that there. Total estimated time 10 minutes and 7 seconds. Alrighty, so instead of 105 minutes to cut out these, or to print out these parts with a 3D printer, it took me, it would have been if I hadn't accidentally turned off the machine because I was trying to manually press the button to trigger my Wi-Fi outlet. It would have taken like 14 minutes probably, including the time to set the parts in Lightburn and adjust the speed and power, which really only took 4 minutes because I was doing it slowly on camera. So yeah, basically like 15 minutes versus 105 minutes to laser versus 3D print. Not bad. Let's take a look at the actual cut quality though. First of all, I realized after I started cutting this, I completely forgot to actually set the focus height of the laser. It just happened to work out to be good enough to cut through. You can see it just barely getting through in some areas, but that's probably my fault for not having focused the laser correctly. Look at that. Decent edge quality. There isn't really any visible charring on the top or bottom surfaces of this. This wood cut's really nice. It smells like a campfire. Same deal with this. Nice light and strong wooden parts. So I randomly guessed that it would take 1/5 of the time to do this, but if we call it 15 minutes, then really it was 1/7 of the time to do this lasering compared to what it would have taken to 3D print it on the Bambu Lab X1 Carbon, which is very fast in PLA, which is one of the fastest printing materials. So the amount of time saved by prototyping flat parts with actual 2D process versus using a 3D additive process is pretty staggering. So I wanted to put some final thoughts on the laser that I am discussing. So the Falcon 22 watt is currently on sale for around $800 US. That's kind of steep, but it is less than the X1 Carbon 3D printer that I have. I think it fits into like the mid to high range price for a diode laser. If you're trying to buy this for yourself as an individual, you don't want to invest thousands of dollars in a high-end CO2 laser or a Glowforge, I can see this being a decent option for you. I would definitely recommend you watch other reviews of similar lasers that are at slightly lower price points. I think this probably provides a lot better value than something with a $200 price tag, and a lot worse value than something with a $2,000 price tag that has a full enclosure and a ventilation system built in or something like that. Because I do think the biggest problem with these open frame diode lasers is, number one, safety, because it's an exposed laser and the reflections can still damage your eyes. So it's better than most, but definitely not perfect. And you can buy an enclosure that's like a fabric enclosure that folds up over the thing for $80, but it has no safety interlocks, so you can still easily activate the laser without that enclosure over it. Whereas most of the fully enclosed CO2 lasers prevent you from even hitting the start button and it doing anything when the lid is open. They'll have an interlock switch. So I would strongly recommend getting a laser like that for schools or anywhere around kids. But if you're an adult and you just want to have this thing to engrave some stuff every once in a while, or even to use for a business and cutting out things pretty regularly or making cool art projects with it, it'll definitely do that. The Falcon will definitely be perfectly adequate for that sort of thing. And the 400 by 415 millimeter work area is a lot bigger than you'll get from a cheaper K40 laser, for instance. So it does have that going for it as well. But yeah, I'll definitely be showing off more things that I find useful to do with this laser in a future video. And make sure to click the link in the description, the affiliate link, even if you're not going to buy the thing, just to check it out, because it does show that people actually are taking a look, at least on the website, and that helps me out quite a bit with these types of videos if I'm ever going to do something like this in the future. I'm probably not going to be looking at another laser cutter because I have no space for one. I just kind of thought this one might be interesting and might have some uses for it, but maybe there'll be other things that I get sent for free in the future. I don't really know. I guess we'll see. I never intend to do any sort of product video on a product that I wouldn't actually use personally. This one just seemed like the sort of thing that was up my alley, so I figured I'd give it a shot. Alright, I think that's all I've got for you today. If you like this video, click like. If you want to see more videos like this, subscribe and hit the bell icon. And as always, thanks for watching.